Hello everyone. In this video we are going to discuss a new topic, that is projectile. We are going to discuss projectile, and eventually we will discuss projectile motion and some of the properties or the basic things of a projectile motion. So go through the video very carefully, and at the end of the video if you find any doubt, then you can post me the doubts. See, when we consider a projectile means if we take, say for example, a piece of stone, and if you throw it in air, so what will happen? It will move and finally it will reach a particular height and then it will drop down to the ground, right? So when we project a body into the space such that it traverses its path and again come back to the horizontal level, is known as a projectile, which is under the effect of gravitational force only. So that you need to understand, when this body is moving in this path, so when it is moving in this path, you will find that along the path, whenever it moves, it is always attracted towards the center of the earth. That is, the gravitational force is always acting on it, and because of which, whether it is in the motion in the upward direction or in the downward direction, it is always acted upon by the same gravitational force. Okay, so this gravitational force we are concerned with for the projectile motion. Now see here, let me take a axis. Let this be the x-axis, and another axis I take, let it be the y-axis. Okay. And suppose a body is thrown from the origin. It is thrown in this direction with a certain velocity, and it will reach the maximum height, and again it will start coming down and it will reach the same horizontal level where it has started. So this is the path of a projectile. Always remember here, whenever we are considering a projectile motion, at any point, whatever is the velocity is given by the tangent to the path. Like this is the direction of velocity, and which has two components. Along x-axis, let it be given by vx, and along y-axis, let it be given by vy. Everywhere you will find these two components. That is, suppose at this point the direction of velocity is tangent to the path, so this is the direction of velocity. So here also you will have two components. One will be vx, another will be vy. So always remember, whenever we are considering a projectile, the velocity, we will always have two components, one along the horizontal direction, another along the vertical direction. Let this be the topmost point. Here the body reaches and it starts moving down. So at this point, the velocity is given by v, which is the horizontal component only, that is vx, and the value of vy naturally will be 0, because at this point it starts descending. So at this point the velocity in the vertical direction will be 0, but velocity in the horizontal direction always remains there, which is given by vx here. Now you need to understand, as a definition for projectile, we can say that when a body is projected into the space such that it moves under the effect of gravitational force only. I am repeating this particular two words, gravitational force only. It is under the effect of gravitational force. So when we are considering this kind of motion, so gravitational force, we know that it always acts in the downward direction. The formula for force is always given by mass into acceleration. So the gravitational force is acting in the downward direction. So acceleration due to gravity in the vertical direction, AY, is G. That is, if you are asked that what is the acceleration of the body which is projected into the space, so in the vertical direction its value is G, which is acceleration due to gravity, because it is acted upon by the force which is the gravitational force only. No other force acts. That means along the horizontal direction, if you are asked to find the acceleration along the horizontal, obviously it will be 0, because the force along the horizontal direction, is 0. No force is acting in the horizontal direction. Only in the vertical direction the force is acting. So vertical direction, the force Fy is the gravitational force only. So obviously if force is 0, so acceleration will also be 0. So therefore acceleration along the horizontal direction is 0. So always remember one thing, whenever we are considering a projectile motion, then in the projectile motion it is always affected only by the gravitational force, because of which we have acceleration in the vertical direction only, which is acceleration due to gravity. Ay is equal to G, it is shown here. And in the horizontal direction, since the force is 0, no force is acting along the horizontal direction, so acceleration along the horizontal, which is given by Ax, is equal to 0. Now when the body, suppose a body is moving, you see here, suppose a body is moving and its acceleration is 0, that means velocity is constant. So it means that along the horizontal direction acceleration is 0, so the value of Vx, velocity along the horizontal, is a constant quantity. Vx is constant. But along the vertical direction the acceleration is there, that means the velocity will change. So we have different values here. So here let it be given by ay1, let this be ay2, let this be ay3. So it will have different values at different places, depending on the acceleration, the velocity along the vertical changes. Okay. Now at any point along the path, if you want to calculate the velocity, it has two components, which is given by Vx and Vy. So if the components are known, you have seen when we have discussed the vector components of vector, then the magnitude of that vector can be given by, like the velocity here can be given by Vx square plus Vy square. So these are the values of velocity at any point. If you know the value of Vx and Vy, then you can find the value of the velocity. Now, so you can also find the direction of the velocity at any point. Suppose we consider this point. Here the angle is beta, which it makes with the horizontal. This angle V makes with the horizontal. Let this angle be given by beta. So in that case, tangent beta, you can see here tangent of beta is opposite by adjacent, that is Vy will be Vy upon Vx. So we can also find the direction of the velocity which is given by tangent beta, which is equal to Vy upon Vx. So I hope this concept of projectile is always clear to you. One more thing you should always remember, whenever we consider, whenever we'll be solving numerical based on this projectile motion, we always take the equation of displacement, which is S equal to ut plus half at square. Now here you will see that there is displacement in both the directions, along x-axis also and along y-axis. So this equation can be written for the displacement along x-axis can be given as x is equal to uxt plus half ax t square, where obviously ax is 0, so the second term will not exist here. And along the vertical direction, the displacement can be given by uyt plus half ayt square. So always remember, whenever you will be using this projectile in numericals, you have to always take care of these two equations: displacement along the horizontal, displacement along the vertical. So I hope that the basic concept of projectile is clear to you. The next videos which will follow, in which we will be discussing when the projectile moves or when the projectile is projected into the space, it moves in a parabolic path. Parabola is a particular shape which is obtained when the projectile moves into the space. So we'll discuss that and other very important properties of the projectile motion that we'll be discussing in the videos to follow. And I hope that this video is very clear to you. Go through the video, and if there is any doubt, must post the doubts. Thank you and have a nice day.